Hello, dear students. Today we are going to discuss certain topics in fluid mechanics and pumps, right? So this is some regarding the characteristic curve of centrifugal pumps. So it is defined as the pumps which are plotted from the result of number of tests on the centrifugal pump. So we are carrying out a number of tests and we are studying the performance. So this curve is necessary to predict the behavior, how your pump is behaving. So you have main characteristic, operating and constant efficiency. So what is the main characteristic curve? Actually, it is you will have variations of head power and also discharge. So it will be varied with respect to their speed. Okay. So say for example, when you are plotting a curve between a manometric head versus speed, the discharge will be kept constant. If you are plotting curves between the discharge versus speed, manometric head is kept constant. So when you are plotting curves of power versus speed, the manometric head and discharge are being kept constant. So you are keeping some variables as making it as constant, and then you are undergoing the test. You can see that this is your power and also head, and your discharge is being plotted on your y-axis, and you have your speed is being plotted on the x-axis. So here what happens here, C and H are constant. So here head, what happens, this is Q is constant. So we are making anything else in this plot, okay, this plot here, Q is what happens here, HL is being constant. So we are making anything, any one variable as being treated as a constant, and we are studying the behavior, how it is varying with respect to the other two variables. Okay, when a speed is varied, how your discharge is varying, like that we are going to learn. Okay, when a speed is varied, how your head, if your head is improved or not, to what extent it is improved, like that we are studying. So operating characteristic curve, in the sense, if you are maintaining a speed is constant and your manometric head power and fluency with respect to discharge gives the operating characteristic. Your speed is maintaining is constant, and the head and power we are varying it. The input curve or the curve for pumps shall not pass through the origin. Why? Because first we need to start up the engine, then only you can get your liquid as discharge. Okay, so first itself you cannot get it, will not start from your 0. So the output curve will start from Q is equal to 0, and the output will be 0. So you can see that this efficiency versus discharge, and the head will be starting from your top. Okay, the discharge you can see, and the efficiency curve, it will be reaching a maximum point and then it will be coming down. Okay, the output power also the same way. So input power, you can see this, how this input power, how it is, and the output power for you will be having for various efficiencies, and also your efficiency is varying here, your power is varying, head is varying, your discharge. Okay, which is maintained constant. Again I am repeating, your speed is maintained as constant. Speed is maintained as constant. You are checking how it is operating under various conditions. Okay, so you can see this operating characteristics. So actually you cannot with this operating characteristic curve only we can learn how we are how it's doing in a various pressure at various heads, and how it is operating. Everything else you can do. Okay, you can see that it will not, you cannot vary. You can see that the input power curve shall not pass through the origin. It will be slightly away from the origin. Okay, even at 0 discharge some power is being needed, because we have to start our power, right? And then secondly constant efficiency curve and constant efficiency curves, and this is being plotted. We can see this cavitation. Okay, so this is actually this is, we can see this will be a constant efficiency curve. HV constant efficiency curve is being plotted for constant efficiency lines. So here we are having head at the y-axis and also discharge. We are drawing for various speeds, and then you are plotting the similar vertical lines so that we get a efficiency discharge curve. Okay. And what is meant by cavitation? So what happens actually? We will have vapor vessels, vapor bubbles will be along settled. Okay, so what will happen actually? Vapor bubbles, when the vapor pressure is below. Okay, so when your pressure is below, what happens actually? Below the vapor pressure, the bubbles will be formed. What will happen when the bubbles are being collapsing with the tubes or anything else? It will be collapsing with high pressure, so it will lead to brittle or tettle. What will happen is actually the LB pipes will be broken off, or it will have small tears or anything else. So we have to avoid the cavitation. So how you will avoid the cavitation? So the pressure of the flowing fluid should not be allowed to fall below the vapor pressure. Okay, if the flowing fluid is water, then absolute head should not be below the 2.5 meters, and the special materials like aluminium, stainless steel ought to be, it can be coated. Okay, thanks for your patient listening.